Today we are going to discuss one important library in the data science, that is the Pandas library. So first of all, we will see what is Pandas library of the Python, what is its significance, and what is the data frame in the Pandas, how do you create a data frame, what is the data frame slicing in the Pandas, how do Pandas handle missing values, and how aggregation functions works in the Pandas. Okay, hello everyone, this is Sharda from GoEduHub Technologies and I would like to welcome you all for this class of Pandas. And can you please confirm me, am I audible? Please write in the chat window, am I audible, clear and loud, and are you able to view my screen? And Merry Christmas to all of you. I'm able to read your chats. Some people have written here, Merry Christmas. Good evening to all of you. Merry Christmas to all of you. So please write in the chat window, am I audible or not? Okay, I got some confirmations. So let's start the lecture. Now we are going to start what is the Pandas. Okay, yesterday I have given the brief overview about the Pandas. Basically, Pandas is a library that is used to do the certain operations over the data. Like when we are using certain data for the machine learning, first we need to do certain operations like aggregation, we need to filter out the data, we need to sort out the data. So these kind of operations we can do with the Pandas. Okay, today we are going to start with the implementation part of the Pandas, like how we can create Pandas. As I already told you, there are the three types of data type in the Pandas. One is the 1D homogeneous array, we call it series, and 2D labeled heterogeneous array, we call it data frame, and general 3D array we call panel in the data frame. So basically Pandas is library for data analysis. Okay, now come to this, how to create a Pandas library. You know, Numpy is the base library for the Pandas. So I hope all of you attended my yesterday's lecture in which I have explained about the Numpy library. Okay, now I'm just directly I'm going to implement Pandas. Okay, so first I'll open Google Colab and then here I'll start the implementation part. Okay, so first of all, it's opening, just wait. First of all, we will create an Numpy array and then we convert that array to the Pandas data frame, or either 1D array. When I have 1D array, then I'll convert this to the series, and when I talk about the 2D array, then I'll convert it to the data frame. Okay, so let me write here import numpy as np. Guys, please do along with me so that you will get the clear concept of Pandas. Pandas I'm taking as PD. Okay, and then I'll need to write here, like I'll create a Numpy array A equals to np dot array, and then inside this I'll write 1, 2, 3, 4. Okay, and then I'll convert this array to series. Guys, are you getting? Just start your implementation part along with me. Okay, okay, now I'll print S and you can check it out, the output. It's running, just wait. Okay, and you can check the type. This is the Pandas series. Here something is different. In place of this, I'll take a characters, certain characters like go, G, O, E, good you have. Now you can see the clear difference because otherwise it's 1 to 1 2. You can see here the first thing is the index. We are getting these are the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7. And here are the values. So in the pandas we are getting data, labeled data. Basically what is this? This is labeled data. Here like in the Numpy you simply get the values, a array, a simple array. But when I talk about this pandas, then we are getting data along with its labels. That's the difference. Okay. So simple 1D array, and here I got the indexes along with this. I can print the type of S. Here you can see the object. Object means when I have some string type of data, then it's object, and when you have integer type of data, then it's integer. You can print the type. Print type of S. Type of S is Pandas series. It's a Pandas series. We have created a Pandas series that is labeled data. Generally, here object means we have some string type of data. Now I'll create, and by default it's providing the index started from 0 to some numbers like 0, 1, 2, 3 in a sequence. I can create a Pandas series with my own index also. Like S1 equals to pd.series. Okay. And here I'm passing numpy random array. Random dot random and 5 values. Okay. And similarly I'm providing here 5 indexes. Random values I'm taking. Okay. And 5 indexes I'm providing here A and then B and then C, D and E. Okay. And now I can print S1. Okay. So this is the random array. I'm creating a random array. Inside the Numpy there is a class called the random, and from there I'm calling this function random. And this basically you can see the different, you can see the documentation, random number generations. Okay, it will generate the random numbers. There are the lots of other functions, like if you want to generate the random number in between some range, if you want to generate some other rand is there are lots of functions. I have used random. Okay, so you can use another function also, but basically it's creating the random numbers. Like I was telling you, uniformly this random is generates the values uniformly distributed over the 0 to 1. In the range of 0 to 1 it will generate the certain values. Okay, and if you want to generate some other values, like you want to generate the integers, then you can use rand int. What, you are not getting the index? Basically here index means I have given like 5 numbers I'm generating and I have provided my own index. So first value assigned index A, second value assigned index B, third value assigned index C. Here I have not assigned any index, I have provided directly the array, directly the values. Then you can say it will automatically take the index started from 0 and will go to the till the number. As many values we have, like it started from 0 and will go till the 7. We have total 8 numbers. Okay, so this is the simple. Here index is started from 0. This is basically, you can say, index in an array you have an index. So here Pandas is showing you the index. Okay. In the first it's automatically, and in the second I have provided. So inside the series function, first thing I am providing here a array, comma, index equals to I am providing my manual index. So you can provide your manual index also. Okay. Now come to the next part. Now we will see, like we have created the simple array, random array, and we can create the Pandas series with the help of dictionary also. Okay, data equals to, I'm taking a dictionary, you know how to create a dictionary. So here I'm taking a dictionary key value pair, like pi 3.14, one pair is this, and second pair I'm taking exponential 2.7. This is one of my dictionary, and I'll print this, print data. Okay, and then what I will do here, s3 equals to pd.series, and inside this I'm passing data, and then I'll print s3. And now you can see the output. Like I have created a dictionary, you know how to create a dictionary, and then how to create a series from the dictionary. You can pass directly the dictionary, and what will happen, the key, it will make the index. Okay, pi is an index and 3.14 is value. Similarly, e is index and 2.71 is value. And this series having values float. Okay, so 3 different ways I have told you how to create the series. The simple, you can initialize a simple array and then you can pass that to the series. Second way, you can pass your array as well as you can pass the index of your choice. But it is difficult, like what happens, we have big arrays, like we have big files. So we never initialize the index of our choice. It will automatically take, because it would be more comfortable for us to work with the auto-generated index. And sometimes what happens, we have a dictionary, we need to convert that dictionary to the series. So we can convert like this. Okay guys, got it? How to create a how to create a series in Pandas. Can you please give me a quick confirmation? Just hit the thumbs up button if you liking the things. Otherwise, tell me the doubt. What the Bindu have written, automatically index didn't came. HIMAB. What you have written? You have written something wrong. Okay, see, got it. That's the thing. Guys, you are not getting the things. Only the 9 likes below the video. Not put here thumbs up. Put like the video. Okay. So just go ahead. We will see the next thing now. Okay. We have created an array we have created a series. Now I'll create the another series and then I'll access the values. Somebody asked me about the rand and rand int. Okay, you can try the rand int. Rand int is nothing, it will generate the integer value in a range. Like you want to generate, I'll use this. How to generate the random values with the help of rand int. Rand int is simply a equals to np.random.randint. Okay, and inside this I'm passing a value. Okay, like 4. I need to print a. What it will do, it will generate, like here I can give like how many values I just want to generate. Here I'm just generating only one more time. I'll run this. It will generate another value. Random value it's generating. Here I can give the range like a lower value and higher value, and in between the lower and higher values I want to generate an values, certain values. Like let me write here, just change it. Size is equal to four to 5. Yeah, it's generating 4 rows and 5 column array, and random value in range of 4. Okay, I can also give the like some range also, but generally in the machine learning we want the lower range values. That's why I'm using here the random.random, because it will generate the values in between 0 to 1. It's generated 4 values in between 0 to 1. So I have created an array that is containing the 4 values. Now what I will do, I'll convert this and then I'll access the elements. So p equals to pd.series, and then here I'm passing a, and I'll print p, and then I'll access the elements of the p. Okay, and in place of 4 here I'll write the 10, so that I'll access them more properly. I have 10 elements. Okay, now I'll do how to access the 4th element. I just want to access the 2nd element. I just want to access a particular row. Then how can I do? That is the similar to Numpy, or you can say list slicing. Okay, so p of 2, it will return you 3rd element, that is 0.67. Okay, and p of colon 2, it will return you 0 and 1st position, elements which are present at 0th position and 1st position. And I just want to get the index of a particular value. Okay, then how can I get the index? I can get the index like p dot index. It will give you the index. Index is basically a range started from 0 to till the stop, and reference is 1. What is the index of this series? We can print the index with the help of this property p dot index. We can get the like we can use other functions also, p dot max, maximum value from this array. Okay, now I just want to get the certain value which are greater than 0.5. Like inside this 5, I want to get the values which are greater than 0.5. So P greater than 0.5. The values which are greater than 0.5, in place of 0.5, I'll write here 0.7. Then less values will come. So we have 1, 2, 3, 4, 5. 5 values are greater than 0.7. Like P of 0, I can access particular element. Here I can provide the condition also. I just want only the values which are greater than a particular constraint. Same function we can use in the Numpy also. Like we want the certain values. Rohit, we have updated all the registration IDs. Yesterday, even like today we have completed all the things. Just check it out again. We have updated these things. Otherwise, just fill the form once again. Okay? Yeah, good evening. Kaun? Mamta Kumari. Okay. So basically what I have written here, P greater than 0.7. I just want to get the values which are greater than a threshold. Okay. Now come to the next thing. I can also use here in place of 0.7, I can use like a greater than median, P dot median. Okay. Now what I want back my Numpy array. Like Pandas series, I want to convert back to the Numpy array. You know how to convert a Numpy array to Pandas? Now I am doing the reverse. Converting series, a Pandas series into Numpy array. Convert Pandas series in Numpy array. Okay. So here what I can write, P dot values. Simply values property I can write, and now I'll get a Numpy array. You can see this is an array. Okay. Now one more property I will apply here. Like what I will do here, S5 equals to PD dot series. Okay. And here I'm generating 5 values in a range 0 to 6. 6 values 0 to 5, and then I'll print S5. One thing, I'm just generating certain values in a sequence. Now what I will do next, like print S5 colon -1. What does it mean? Colon -1 started from 0th and will go till the second last. Colon -1 means I'm getting till the 4 only. I'm not taking the last element. Okay. Similar thing, what I am doing here, print S5 of 1 colon. It means now I'm starting from first, I'm not including last. In this, I'm not including the last one, and in second, I'm not including the first one. But both having the same size, like 5 elements in this and 5 elements in this. Now if I'll do the sum operation like this, S5 colon -1 plus S5 1 colon, then what will happen? You can see in first set we don't have 0th element. in the first set we don't have last element, and in the second set we don't have first element. So what will happen, at the both the values sum up corresponding to the index, like from the first, here we have 0th element, but in the second we don't have 0th element. That's why here it will put NaN, not a number. Then first index we have value in this and we have value in this also, so it will sum up. So 2 value. Similarly for the second and for the 3 and for the 4. Now 5 index here is available, but in the first there is no 5 index. So in the 5 index also we are getting NaN. Are you getting? What I want to tell you, it's a doing operation element wise, index wise. It's not printing the 5 values. The values which are greater than 0.7, it's printing all the values, Mamta. Just check it out again. Mahesh is asking a question, P4. What is the P4? Print P4. P4 is this one, 0.71. Okay? Please focus, guys. What I am telling you is these are the very important properties. Here I have taken S5 that having 6 values started from 0 to 5. I have generated a series that having the values in the range of 0 to 5. Okay? And then what I am doing here, S5, first part I am taking colon -1. It means I have started from 0th index but not taking the last one. So 0th to 5th index, 0th to 4th index. First 5 elements I am having in this print, and then last 5 elements I have in second print. I started from 1 and going till the last. Then what I am doing here, summing both S5 colon -1 plus S5 1 colon. Then what happens here, it's a summing index wise. So in the first case we don't have last elements, and in the second case we don't have first element. So in place of first and last element we are getting NaN in the output. Okay? Got it, guys? Now it should be clear to you. It's a summing index wise. Now we have seen the lots of things in the series. Now one more thing we will do here. PD equals to, I'm generating one more series. Okay? PD.series and random number series, np.random, and inside the bracket I'm putting 8 values, or I can say 25 values I'm generating here randomly. Print. I don't print because it will take lots of space. Okay, let me print PD. Once I'll show you 25 values I have. Okay, then what I will do next, I'll print top 5 records, like top 5 values, or you can say top 3 values only. Print PD. There is a function called head, and inside the head I need to pass certain values. Like inside the head I'm passing here 3. It means it will print first 3 row records. Now I can run this and you can see what happened. Okay, P1, I'll give it name number to P1 because PD is already object of pandas. No attribute series. Okay, I need to import the pandas. Let me write it. Import pandas as PD. Now it will run 100%. Yes, actually I have assigned a local variable to the PD. That's why it's creating a problem. Import pandas as PD and PD.series. I'm generating 25 random numbers, then printing this, and P1.head3. It means it will give you these top 3 rows. Now you can see the output. Top 3 rows. Okay. 0.36, 0.90, 0.07. You can see here 0.36, 0.90 and 0.07. Now I want last 3 records. Print p1.tell. Tell is a method that will print last 3. 22nd, 23rd and 24th. To print the first 3 and number of first, inside the head you need to pass the value p1.head. It will give you the starting values, and p1.tell, it will give you the last records. Okay. Mohit, you are getting the wrong things. It's not 5 plus 1 equals to 5. In a one series we have value at particular index, and in the second series we don't have value at particular index. It's a summing index wise, like values at index 1 will be summed with the values at index 1 in the second series. If both series have the value at particular index, then it only sum, otherwise it will put NaN. So here you got it. 2 important functions I have used. One is the head and one is the tell. Head is basically giving you the top records. Tail is giving you the bottom records. Okay. I'll comment this and again I'll run this so that output would be here. P1 I'm not printing. Head 3, it's giving you top 3. You can see, how can you identify top 3? Because here the index you can see 0th, 1st and 2nd. And bottom 3 is 22nd, 23rd and 24th. Similarly, I can convert a pandas series to Numpy array. How can I convert? Using the values. P1.values, it will convert to the Numpy array. Okay, it will convert the pandas series to the Numpy array. Now I can check the data type also. Print p1.dtype. Data type of p1. You can see float 64. And you can check the type of p1. That is the different thing. Type of p1. Type of p1 is basically pandas series, and values inside p1, its data type is float 64. We have converted this pandas series to Numpy array by using values. It's only for this current statement. It's not assigning the Numpy array because we are not assigning. So by default our p1 is still having a series, but for checking the output we are putting here p1.values. These are the important properties. Okay guys, are you getting the things? These head, tail, values, data type and type. Everywhere we are going to use these functions. That's why I am taking very slowly now. Okay, so this is the series part we have completed. Now what we will do, we will take a file and we will work with the file. We will see a data frame part. Introduction part, like 1D array we have seen. Now we will come to the data frame. 2D array. What is the data frame? I'll tell you. Data frame is two-dimensional, size mutable, heterogeneous tabular data. You have seen in the 1D array, in the series, we always taken the one type of data, either float, either integer, either like a string, but we are taking only the homogeneous data. But when I talk about here in place of series, I'll take the another function, that is the data frame, that is for the 2D array, and in 2D array we are taking heterogeneous tabular data and data labeled with the row and column. We can thought of a dictionary like of a container to store Python series objects. You can say collection of series objects. Here same properties we have axis, we have column, size, shape, values, d types, all these functions we have. Here also we have size. We can check the size of this. Print p1.size. You can print the size of p1. It's a 25. So all these functions we have here, we apply with the data frame also. Some methods like minimum, maximum, standard deviation, mean, median, and then head, tail, all these functions we have in data frame also. Okay, so let's see how to create a data frame. First of all, we can create a data frame like this. I'm picking this statement and I'm putting here. Okay, now you can see what I have written. A simple dictionary. You can say the pd.dataframe. This is a function pd.dataframe I'm using. Inside this function, we have collection of series. This is one series and this is another series. And then we also have, like, you can run this, then you will see the visualization df. Output is look like this. What is this actually? Alice, Bob and Charis. This is one column. Series is only 1D. And then second column is 21, 25, 23. This is the second column. And we need that some title for the columns because it will give the rows index 0, 1, 2, 3. Similarly, we need for the columns also. So columns we have to provide here. So name and then the series, age and then the series. So name is the header for first column, age is the header for the second column. You can say data frame is collection of series. Okay, the simple series I have created. Now I just want to add one more column to this data frame. To the same data frame, I just want to add one more column. Then what I will do, like in the dictionary, I can add the columns like this, df of something. So here I'm writing height. df of height equals to, I need to provide one series. Okay, and inside the series I need to provide certain values like 5.2, 6, 5.5, some certain values. And now I can print this df and you can see the output. One more column is added, that is the height. Like what it will see, df, this is how to add a column in the dictionary. This is like of that. df of height, it will check is there any column of this name? No. So it will add this column and these values in this column. Okay. Somebody is asking a question, how to make Alexa and it will spell any name. You cannot make the Alexa directly. You need to understand the basics first. Then only you will go to this. This is a big project. You cannot go directly. First you should know the ABCD. Like when you are in a KG class, you cannot study a particular subject. A maths sum you cannot solve. First you need to know the counting. Okay? So I'm telling you that counting part. These are the ABCD for the data science. Or you can say for the machine learning. Now this is the 2D series we have created. Now what we will do, we will download a file. Okay? And all these work, like this is a, if you have a file and in the file, a Excel file, you have certain rows and certain columns. Then you can work over that file using the data frame. How can we work? So what we will do, we will take a file. What you guys can do, go to the description of this video, and in the description of this video there is a link, second link in the reference note. Second or third, let me check it out. Data frame in Pandas, that is the second link. Open this link, second link in the reference notes, please, below this video, second link in the reference notes, please open that. And in this link, if you go downside, here is a like how to read CSV files. Here is a file, you need to click here and you need to download this file. This is a CSV file, we are going to work over this file. Very small file, it has certain columns, like we have a data set of salaries like certain professors, then discipline, then PhD, and then their service, sex and salary. All these things we have in this file and we are going to do certain operation over this file. So please download this file first. Okay, I have downloaded this file. I just want to save at my desktop. Okay. You can download at your choice, whatever the place you want to save. And now we are going to read this file. Fajan, can you please explain what you are making and what the steps you have done till now? Have you done some work over this? It's a good, if you are working over this project, that's the good thing. But first you need to tell the other people also what you are doing, till what step you have done. Till now, what are the steps you have completed? Then only we can help, otherwise how can we help? We cannot give you the code, you can run that and you can directly implement the project. It won't possible. Okay, so guys, I hope all of you downloaded this file and now I'm going to read this file. I'm going to work over this file. Okay. So what I will do here, I'll write a command df data frame. You can give any name to this variable, pd.read_csv. This is a simple name and here you need to provide the path of that file. Okay, salaries.csv. Now we are working over the Google Colab. Then what we need to do here, a files folder, you can see in the right side, fourth icon is files folder. You need to click here and here upload to the session storage. This upload icon, click over this and here you need to select your file, which file you have downloaded. Salaries.csv. And this will upload a file here, salaries.csv. I'm closing this part. What you need to do, one more time I'll repeat, download this file, salaries.csv, and then here files icon, just go here and this upload icon, and then you need to choose that file. Like my file name is salaries.csv, open here and then it will upload here. You can view the file salaries.csv. Okay guys? Somebody is asking from where you have downloaded this file. Please, below this video description, we have provided the reference notes. In the second reference notes, you have to open the second reference notes and then go down in the answer, go down and here Pandas series, and after that, no, which one is, I have opened the wrong one, data frame. In the second, let me open this, I'll again tell you, I have closed that. Pandas data frame, second link, just open. Second link is this. Second reference notes is what is the data frame in Pandas, how do you create a data frame. And go there, in the downside, you have to see there how to read CSV file. Download file, click here. If you click here, you will go to this salaries.csv file. Okay? Just download this file and then start reading this file. I have read this file, this, and then I can print DF. And this is the data inside this DF. Okay, so pd.read_csv salaries.csv. Guys, what you need to do, one more time I'm just repeating, go below this video description, second link, second reference notes, what is data frame in Pandas, how do you create data frame, link, open that link, and in that link just scroll down, what is data frame in Pandas, how do you create a data frame, just scroll down. In the answer part, you can see here this example, name, age, height, and then there is a link how to read CSV files, download file, click here. If you click here, you will see a file is available and then you need to download that file. After that, in the Google Colab, the last option, fourth option is files. Click over this and then upload option, upload the file here. Salaries.csv would be placed here. And then you need to write this code, pd.read_csv, and inside the double quotes you need to put the file name. S should be capital, same name, whatever the name of your file, salaries.csv. And we have read the data inside the DF and then we are printing the DF. Okay? I hope most of you have done. Now I'm going ahead and I have just printed this df. Now I just want to print df.head. Only top 5 rows. Okay. In place of complete df, I just want to print df.head. And you can see, guys, I got only top 5 rows. CSV stands for comma separated values. It's a file. It's a type of file. Comma separated values. That's I'm telling you, Prince. Just wait how we will use these library in this machine learning. Just wait. Just see, first learn these things. Like we have taken a data file now. So what we are going to do in the machine learning, what we need to do? We need to take certain data first for training our model. So taking that data, then we need to process that data. So what we have taken a data of certain professors. And now we are going to work over this data. Top 5 records I have printed, and then top bottom records I just want to print using the till. Okay? These are the bottom 5 records. And then I'm using another property like print. Everything you can put inside the print so that it will give you the output. Print this. Otherwise, it's print only the last value. And then I'm printing print. I'm checking data types. I'm checking how many columns here in my data. So df.dtypes. I'm checking data types. You can see here. The data type is, like you can see here, we have inside this data, we have certain rows and certain columns. Column name is, first is rank, then discipline, and then PhD, then service, and then sex, and then salary. These are the columns we have in our file. You can cross-check with the file also. And if I just want to print only the columns, then I can print the columns. What I'm doing here, I'm analyzing my data. What is the data I having? I just want to you are working in a company and you just want to work over some project, and your boss have provided you a file and you need to make a project over that data. So first, what you need to do? You need to check out the data, what the data we have, how many columns we have, how many rows we have, and what type of data we have. All these things we need to check it out. So columns, you can see here, we have how many columns? These are the columns. Rank, discipline, PhD, service, sex, and these are the columns. Okay? Head, tail, D types and columns I have printed. Similarly, I can print another things like print df.axis. What are the axes? Axis means it will provide you both things. Rows started from 0 and will go till the 78. Step is 1, and index is columns. So I got rows and columns, and data type is object type. Object means it is string combination. It's not purely integer, it's not purely float, it's a combination, then we call it object. Okay. Similarly, I can print df.axis. I have printed dimension and you can see dimension is 2. Means our data is 2D data. Number of dimensions. Similarly, I can print df.size. Size is total number of values. 468 values I have. Similarly, I can print df.shape. Shape, you can see how many rows and columns. We have 78 rows and 6 columns. If you multiply 78 by 6, then you will get 468. That is the total number of values. Yes, for other type of data, we have certain other functions in the pandas. So you can check out that. There are lots of functions available. Here I am just working over the CSV file. Okay. Size and shape I have checked. Now I just want to check out certain statistics of this data. Like what type of this data? In a single command, I can check describe. df.describe is a function that will give you certain statistics. Like for the integer columns, it will give you the count. Count means total number of records. Mean for PhD column, particular column. Mean for service column, mean for salary column. Similarly, standard deviation, minimum values, maximum values, 25% of total value, 50% and 75%. So some little bit statistics about this data at a glance. Are you getting? What we have seen lots of things from this data. We simply taken this data and then we are taking certain properties over this data. I just want to access certain rows, certain columns. These things I want to do. So head is top rows, bottom rows, and then data type, then columns, column name I just want to know, then axis, dimension, size, shape, describe. Now there are the lots of properties available. Now I just want to access only one particular column. I don't want all these 6 columns. I want only the salary column. Then how can I access? I can access the salary column like this, df, and inside the square bracket, I need to write that column name. This is salary column. Only I'm getting the salary column. Now you know how to access a particular column and you know how to access a particular row. Like I want to access 6th row, then I can access. Sorry. Here I need to provide one more thing. Let me write that. We need to provide both the axes, rows as well as columns. So that I'll tell you, just wait. Okay. And I just want the mean of particular column, like mean of total data. Mean of total data, you can see df.mean. When I apply a function, then what will happen? It will check the numerical columns, like column which have numerical values. So PhD column have numerical value, service column have numerical value, salary column have numerical value. So mean I am getting for all 3 columns. But now I want mean for a salary column only. Then what I can do? df, I can access particular salary column and then I can get the mean. Okay. Now you can see df.mean is providing mean for all the columns that have integer value, and df And from the df, I'm only accessing the salary column, df salary. And then I'm applying this mean function. So particular salary column mean, you can cross verify from here. This is the mean for the salary column. Yeah, just wait, Suraj. I'll use those functions ILOC, LOC. So that's why I have not told you now. I'll tell you those functions also. Okay. So what we are doing certain work over a file. We are accessing certain things from a file. We just want the person who are getting the maximum salary. We want the person who is getting the minimum salary. We want the female professors who getting the salary greater than 80,000. We want the male professor who getting the maximum salary. So we want to solve these type of questions. This is data analytics. Okay, Fajan, I'll try. I'll make the video for that also. Okay. Now come to the next thing. I can access particular rows. I can access particular columns. Okay. Let me use one property, that is the grouping the data, slicing and grouping the data. I just want to slice the data. Okay. Data slicing and grouping. What is the data slicing and grouping? Like I just want to extract a particular part of data and then I just want to do the group. Like here, lots of students are studying in this class. I just want to group them according to their year. Like we want the first year students, then second year student, then third year student. We want to make a group like this. Okay. So that is called the grouping. So here inside this data frame, what we have for the grouping? df underscore rank equals to df. There is a function called group by. And I just want to group by a particular column called rank. Okay. And then df underscore rank dot mean. Now you can see what I have done here. Rank is a column and rank have 3 unique values. One is the associate professor, then assistant professor, and then professor. So we made the group according to the rank and then we got the mean value. So associate professor mean value is this, and assistant professor mean value is this, and professor mean value is this. If you want to print this df underscore rank, then it won't give you the value. Basically, it needs certain operation with it. We need to apply a function over this. Then only we will get certain data. Group is nothing. After the grouping, you need to do the certain thing. Like we are making a group, and from the group we want to do the some. Over the group we want to do some operations. So here from this group we want to get the mean values. Okay. Now we want to get the mean value of male and female professors. So we want to do the grouping by using the another column. Okay, so first of all, I have applied here a grouping. Now I'll take a one question like mean value for male and female professors. Then what I can do? df dot group by. In place of rank, I'll change the column name as 6. Okay, and then I'll use the another thing. After the grouping, what I can do? I can get the mean. Now you can see male and female, I'm getting the mean value. Now I don't want to see the PhD and service. I want to see only the salary. Okay. Mean value for male and female professors, I'm getting like this. Just grouping, I'm changing the column name only. Okay. And I don't want to see all the columns. I want to see only the one column. Then what I need to do? I need to select only one column, that is the salary. Now I can run this. You can see, now I am getting only one column. Otherwise, you can assign another variables. Like here I have assigned one variable, and then you can write like this, df of rank, and then here you can write a particular column name, PhD suppose. Then you can do like this. Both are the same thing. Like first I have grouped, and from the group I just want to access a particular column. And then I'm applying the mean function. You can apply any aggregation function here. Mean, max, median, whatever you want. After the group, we always need a aggregation function. Okay. So here df dot group by, and then I'm taking a particular column, and then I'm taking the mean. Yes. It won't work. Bindu, just check syntax. If you want to access a particular column, then you need to put into the square braces. Okay. Similarly, we can do the other things also. Like this is for the ranking. We can do the sorting also data. Like we just want to sort the data, we can sort the data. And we can do the filtering. So I'll do one more operation that is called the filtering. Okay. In the filtering, I need to provide certain conditions. Like I want only the person whose salary is greater than 1 lakh. Okay. So what I will do here? Like I just want to access a particular column df salary. I can access like this. Now I just want to put a condition like salary greater than 1,60,000. Okay. I want to get these persons whose salary is greater than 1,60,000. I can run this. And you can see I'm getting only true, false. Because this is a condition, either true or false. I need to put this condition inside df, and then this. Now I can run this. df, and inside this df, I'm putting a condition. So the person whose salary is greater than 1,60,000 are the 3 persons in our list. Okay. Now I'm giving you a question like you need to try it out. Find mean value of salary for discipline A. Find mean value of the salary for the discipline A. Try to solve this one. Find mean value of salary for discipline A. What we need to do? Here we need to do two things, filtering according to the discipline column. And we are going to put the value like this, df, and then discipline column. We will put the discipline column, and df discipline equals to A. Okay, this condition we put inside df. Okay, and then we will apply the mean function, right? And now you can see we are getting the answer for this. And I just want only the salary, then I can put here the salary. Okay. This is only the mean value of the salary for discipline A. Okay. Mean is the average. Now I'm providing a challenge question to all of you. Please try this question. Extract only the observations with the high salary greater than 100K and find how many male and female professors in each group. Till now, whatever the concepts we have covered, you can solve this question easily. Mean is basically average value. You don't know the mean or you want to do the project of Jarvie. Okay guys, just try this question, challenge question, only observations with the high salary. Greater than 100K, I have put it in the comment section. Please try this question. Okay? I have tried so many things in Pandas. Now some little things are left out. Just let me check it out. Like slicing part we have done, certain functions we have applied, and we will see some more things. Pandas slicing part and missing values and aggregation functions. 3 things we have to complete. Okay, slicing part is more on the slicing. Single column access we know. How to access the single column? Like this we know. Select multiple columns, then you can access like this, rank, comma, salary. Okay, you just want to access certain rows like 10 to 20, then you can write like this, df 10 colon 20. Okay, and you just want to access particular rows, then you can use the LOC and ILOC functions. Like ILOC is for the position for the columns. And LOC is you just want to give a range of the rows and then you can give the name of the columns. Okay guys? It's okay, don't worry. Just try your project, that's good thing. Pratik, what's the issue? It's a giving none. Okay, so basically slicing part, you guys can please read it out. This is simple. We have to try two functions, LOC and ILOC. Okay, shall I need to write these things or not? Aggregation functions, we have covered most of them. Like aggregation functions, what? Describe function is providing you basic statistics. Min and max is minimum and maximum values. Mean, median and mode, these will give you the arithmetic average, median and mode. And variance and standard deviation, you can use var and std. And standard error mean and skewness and kurtosis. All these functions are some functions of statistics that we are going to use as in the form of aggregation function. Some of them most frequently used we have tried here. Okay, and then how to handle missing values in the pandas. This is also a big topic. Like what we can do, we will take a file and in that file there are the certain null values and we can handle that null values with the help of pandas function like drop na, and there are some variations of drop na is null, fill na. So we will see that in the another class because it will take the time. So missing values I'm leaving now. Other things like slicing and aggregation we know, and slicing part I'll show you. ILOC and LOC functions I'll show you. Okay, okay, slicing part I'll write, don't worry about it. Like a particular column, how can I access? We know that df of salary. Okay, this will give you the single column. I just want to access one more column, df of rank. Salary and rank, two columns I want. What happened? I need to provide in a square braces. Okay, because these are the two columns, I need to provide in a braces. It's a array basically. Now you can see I'm getting two columns, salary and rank. Slicing I'm doing over the data slicing. Two columns I'm getting, single column I'm getting. Okay, then select the rows. We just want to select the rows. So we just want to select only 20 to 25, 5 rows from a particular location. It's giving you 5 rows, 20th to 25th. Okay, now we will try the function ILOC and LOC. Okay, so df dot LOC, and then I'll write inside the LOC, I need to write the rows, specify the rows as well as the column. I want particular rows, like from 20th to 25th row I want only two columns, 20 colon 25th. Okay, and I want two columns, rank as well as salary. Okay, I hope this will work. Yes, I'm getting rows from 20th to 25th and columns I'm getting rank and salary only. This is LOC. Similarly, suppose for the columns I don't remember the name of the columns. I just want to access the columns by the index. Like here I am accessing the rows by the index. Similarly, I just want to access the columns by the index. Then I can use ILOC. df.iloc, and then here I'll pass 20:25, and then inside the braces I'm passing 0,2, 3. Okay, let me run this. Yeah, this is giving you 0th column and then 4th column. Like first column and 4th column. And rows as you specified. Okay, so this is called the slicing. We can do the slicing over the data. Yes, Suraj have written ILOC for integer, LOC for string type. Basically, you just want to tell here the same thing. When we are putting the column index, then we are using ILOC. And when we are putting the column name, then we are using LOC. Okay, so this is the slicing. Similarly, we can do the sorting also. Sorting. Okay, how to do the sorting? For the sorting, we have some functions. Like df dot sort by values, sort underscore values. This is a function, and I just want to sort by a particular column, service. Sort by service. What happened here? Service is 0, 0, 0, then it's increasing. 36, 43, 45, 49, 51. So by the service I have sorted, or either I can sort by salary. You can easily visualize. Sort underscore values means here I'm providing a column name and I'm sorting by the salary. So you can see first person who having a minimum salary, then increasing the salary. Similarly, we can sort by index also. And we can write also here the sort order, like here by default it's sorted in ascending order. We can sort in the descending order also. Like here, comma, I can provide one more parameter, ascending. Ascending equals to false. Now it will sort in descending order. What happened? There is some typo mistake. ASC. Okay. And what happened? It's not taking. I need to provide in braces. It should take. Let me check it out. Why it's not taking? Yeah, now it's work. It's a taking in the braces. So I need to provide this parameter like this. Ascending is false. So it's in descending order. Maximum salary person is at first row. Okay. We can sort by column and then we can sort by order also, like it's a increasing or decreasing. Similarly, we can sort by index also, df dot sort underscore index. Okay, and then here we can write like if you want ascending or descending, sort by index. Here I'll provide ascending, ascending equals to false. I'm taking ascending equals to false. Yeah. Now it's a index wise in descending order. 77, 76, 75, 74, 73 like this. Okay. So this is called the sorting. We can sort the data by a value in column. By default, sorting will occur in the ascending order and a new data frame will be returned. Okay guys, I think this is enough for today, and if you have any doubt then you can ask me. Yeah, I for integer. Or either you can see the like meaning of I in the documentation of Pandas. As for my understanding, it should be a integer. Sorry, it should be index, not integer. You can check it out in the documentation. I don't remember the I meaning. But when we want the index, then we take the ILOC, otherwise we take the LOC. Why we use false? It will work without false. Actually, when we are writing false means we are in decreasing order. We are not writing anything by default, it's in increasing order. Okay? So today we have seen like data frame implementation part, like how data frame works if you have certain data, and then how can you extract the particular data from a file, data of your choice. Okay guys, thank you so much. Bye bye, good night, see you tomorrow. And don't forget to write your attendance.